Okay. And a good morning to everyone. And that was Chicago with the Blues Brothers. And that is, I don't know, there may be other songs in there that are equally noted. I think Aretha Franklin's Think is as good as any. So, Ernie, we may do Think at the end with Aretha Franklin, but the Blues Brothers with Chicago is, man, that's good stuff. I like the arithmetic in it. 6 and 3 is 9 and so on. Just have to do that. We're going to do a little bit of review again today. We're trying to spend some time with counting and formulas just to keep it in front of you so you don't forget. So a new problem in counting. I'm going to reverse the one I did the hour ago. I'm going to have you start with a base 10 and go to a base 6. So starting with base 10 number, I want you to write it as a base 6 number. So here is my number, Ernie, as I go to the boards. 9, 5, 5. That's base 10. So I'll just identify it as our usual base. And I want you to give it to me in base 6. So have fun. We'll just leave that up there for a moment. I'll walk off camera just for a moment. We'll just leave that there because people watching this afternoon may want to have fun doing this. Remember place value. And I know you may feel I have a perverse sense of fun. But base 6 is so neat. Okay, so you want to write this as base 6. Hint, get the largest place value that will still go into 955. You're going to do some division. So we'll give you just a moment or so to give a try. If you think of place values, largest place value in base 6 that will allow you to divide into 955. That's the key. So we'll see how many of you have got a start on this as opposed to staring at the wall. Okay, that's something I do sometimes when I'm trying to think of a solution. Just stare at the wall, hoping for something to pop into my head. So let's see what happens here. Okay, now, first step, just so come back to that. I have some place values I'm going to write in here, so I'll just please leave some spaces. So I start with what? The ones place, then what? The base itself, always in your next spot. So that holds no matter what base I have. The ones in the first digit in the right, the base in the second, and then how do I get any other place value? Multiply by the base, which in this case is 6. So I'm going to go this way, multiplying by 6. And so your 6 times 6 is your 36. And then we go to 216. That's what you should have been able to do as you started this. Now your next place value, by the way, is 1200 something. That's bigger than 955. So I don't have to worry about anything more than 216. So if you were not able to get this far, now you should be able to start by dividing 216 into the 955. So give that a shot and let's see what you get. So you're going to divide the 216 into the 955. The 216 into the 955. Are you playing golf? Okay. I heard somebody say 4. Tiger's not in the room, so. Okay, so that is a division. Let's see if that is correct. 2, 5, I did it again. 216. 216. I did that earlier. Made it a 256. There's a reason for that. It has to do with computers, but okay, so this is into 955. So we've got a 4, and that does end up 864. So getting that much, of course, I'm going to subtract, and I get a 1 here, and then a 9 here, and that's it, correct? Now that means I can do something with that 4 immediately. Now, what camera are we on at this point, Ernie? Okay, can you take camera 1 and just give me the left side there so we can flip-flop between the cameras? I like that as a phrase, flip-flopping the cameras. Feel like we're at the optometrist. Lens 1, lens 2. I'm ready for lens 1. Now, that means I can put that 4 over here because I have 4 of those. So what's my next place value? 36. The 36. So, going back, I'm going to take 36 into what? 91. The 91. And I hope you realize that's going to go 2 times. So we get a 72. And that's going to give me what? A 19. Now, isn't that interesting? I had a 9-1, now a 1-9. There's nothing significant about that, but it is intriguing. Okay, Ernie, back to the other camera, please. And as I come back here, I said I had 2 of these. So now, what's my next place value? 6. The 6. Okay, coming back over here, I'm going to take 6 into this 19. And that is a 3 with a what? 18. A 1 left over. So let's go back to the other camera. So I have 3 of these and 1 left over, and I have made my transition from base 10 to base 6. How many of you got it? 3, 4 of you? That's not making me ecstatic. Okay, so need to work on that. Now, how would you go the other way? Starting here and go this way. Reverse the process. What would you do? Multiply what? Okay, and then the next one, and then add them all together. Okay, and what's that called? Now, let me verbalize what I heard, because people listening this afternoon didn't hear the comment, and it was multiply the 4 times 2, 16, multiply the 2 times the 36, and so on, and add. What is that called? Expanded notation. So if I write 4, 2, 3, 1 using expanded notation, that means I'll take 4 times 2, 16, which will be your 8, 64. And I'll multiply the 2 times the 36 and get my 72. And I'll multiply the 3 times the 6 and get the 18. And the 1 times the 1 and get 1. Add all that together and I will get 955. Okay, that was counting. Formula time. Let's see what we can remember. Going for 4 is what we're trying to do. We did this yesterday. Let's just do it again. We're trying to remember some formulas from the formula unit. So on camera 2, we're going to go to the space I have over to the right side. So I'll wait until the camera stops, and I'll know then that I can go there. And formulas. So let me just choose a formula to start. Perimeter. Right triangle. Formula for the perimeter of a right triangle. You do not get to look at your cards for this one. This is just from memory at the moment. Perimeter of a right triangle. And I'll give you another one so that maybe while you're still thinking of that one, you can get this one. Area of square. Area of a square. Now, don't say anything. Just write so that everybody has a chance to write the correct formula from their memory. Then, a volume of, I'm going to put in quotation marks here, box. Technically, it's a rectangular parallelepiped. A rectangular parallelepiped. A box, like a shoebox, the volume of that. And then finally, the circumference of a circle. So I'll just draw a circle with a dot in it. Okay, those are the 4. Let's see if you can go 4 for 4. Give you a chance to write them out. And a special note for Adrian. Remember to put perimeter and area and volume and circumference on the left side. Just a minor reminder. No, I won't give that help on a test. Okay, what was the perimeter of the right triangle? Somebody have that? And the silence. B starts with a B. Good. You're thinking of times and you want what? Plus. So your base plus the height, and what's the D stand for? Diagonal. So B plus H plus D. Base plus height plus diagonal. And you have to be a little bit careful. What else does D stand for? Diameter and distance. So we use that little letter D for a lot of things, including 3D, which is dimension, 3 dimensions. Area of a square. This one's simple, but sometimes hard to get right. What is it? Okay, nearly. 4S would be your perimeter. Now, S2 sounds like R2D2 kind of thing. S2, I hope you mean S to the second power, S squared, side squared rather than side out. Okay, so side squared, S times S. Okay, the volume of the box. Whoa, that was fast. Length times width times height, or just what? LWH. Okay? Length times width times height. Okay, the circumference of the circle in 2 different formulas. Okay, the pi r squared is a great area answer, but not for circumference. See, the r squared would give you square feet or square meters. And when we do circumference, we just want feet or meters. So you aren't going to have r to the second. You're going to have an r to the first. What is it going to be? 4/3 pi r cubed would give you cubic something, and that's a great formula for the volume of a sphere. But I want the circumference of a circle. Lewis, do you have it? Now you're thinking of the volume of a sphere again. I want the circumference of a circle. Somebody else? Are you asking me? Adrian's asking if it's 2 times pi times r. Maybe. Is he right? Okay, that's what it was written as, right? 2 pi r. But not with authority, I can tell that. Give it to me in another form, because 2r is what? 2r is equal to what? Diameter, which we use the little letter d. So what's another way I can write the formula? Pi d, or d pi. That's an alternate. But that's not the same d that was up here. This is diameter, and this is diagonal. So multiple use of the letter d. Anybody get 4 for 4?
Sure.
Once I gave them to you. Anybody 3 for 4? Okay, a couple of you 3 for 4. We're still not to the magic 4 for 4.
I haven't had a chance to study.
Okay, I accept that. Moving, Merlot, that does put you at a disadvantage. Merlot helps. Listen to that. Now, okay, Ernie, I should have telegraphed where I was going. Sorry. In terms of reviewing, a reminder that at the end, now we're only in the 6th week, but they're only 15, so things are moving fast. Next thing you know, it's Halloween. Then it's tryptophan.
Is that a drug?
No. It's turkey. Okay.
It is a drug in turkey.
Well, but it's what
a
you get.
chemical.
Yes, it's a chemical that you eat with the turkey, and then you get sleepy and have Merlot. Now, the idea is at about post-Thanksgiving into the Christmas holidays, we're going to take a final. And you need to remember the formulas, and you need to remember the counting unit and all the other ones we do. So I'm going to try to keep those in front of you as we go ahead and finish out the computational review. So we did for yesterday 16, which was multiplying decimal numbers together. Today it's division that we're going to look at. Tomorrow, percents, and that gets us up through 18. We need to then think in terms of a quiz on 14 through 18 and having your book done with that, because we then go into a midterm where in 1 hour you get to do 30 questions from the 18 reviews. And that's 400 points, which is a major impact on your grade. Yeah. So you need to think about reviewing, reviewing, reviewing. And that means doing more problems and more problems and more problems so that you get very good at it. And you can do a problem in 2 minutes. So any problem we talk about, 2 minutes, because you'll have an hour for 30 questions. Okay? So let's look at 17. That's what we're doing today. We're doing division. And one of the interesting things in this is we have done the change of a common fraction into a decimal. Remember how we did 1 over 4? We divided 4 into 1 and got 0.25. So let me come up here to the front with the space I have, Ernie. I'll go over to there for a moment. So just to review, we wanted to change this into a new fraction in essence. We wanted a denominator that was a power of 10. So what we did with 100, which is a power of 10, we said I could multiply this by 25, this by 25, and I could get 25 over 100. And that is 2 over 20 over 100 plus 5 over 100. That reduces to 2 over 10 and 5 over 100. You're saying, why didn't you go to 1/5? Because if we look at our decimal to the right of the decimal point, remember we have 1s and 10s, but to the right we have 1 over 10, 1 over 100, agreed? And so I have 2 of these and 5 of these, and that's how we get our 0.25. Now you don't want to go through life doing all that, so we did a little shortcut called division. So we said, let's take 4 into a 1, put a decimal point, and throw some zeros after it. There is no rule of thumb for the number of zeros. They're cheap. You can put as many as you want. So I might throw another one at it just for good measure. And I try doing the division. So 4 into 1 will not work, so I put a 0 there. I go 4 into 10 is twice. That gives me an 8. I subtract. That gives me a 2. Bring down this 0. The 4 into there goes 5, and you say, aha, 0 remainder, I'm done. And we call this what kind of decimal? Think of our governor. He is also known as the terminator. It's a terminating decimal. Okay. I know that's a reach. A terminating decimal. Now, sometimes instead of terminating, they do what? They repeat. So 1/3 becomes 0.33333 into the night, and so we put a little bar over a 3, and it can be repeating. Keep in mind, every common fraction either becomes a terminating or repeating decimal. We know how to do that problem. That's where we've been. Okay, question.
Just a simple question. Say it was 3/4. Would you divide the 4 into 3.00?
Yes.
Okay.
The question is, what if it were 3/4?
That's what got me.
Would I divide 4 into 3.00? And the answer is yes.
Okay. We were arguing on that.
I wouldn't know why you would argue. I mean, no history in that. Now, so you bring some Merlot, it would be a much more pleasant argument. Okay? Unless you like cabs. Yeah. A lot of good that's going to do then, right? Just water. Good old mineral water.
That's my second favorite.
Okay. Now, the question. Ernie, I'm going to come back to the center for a moment so you know where I'm heading, and then you're going to kick camera 2 to the side. And so I'll come back to what we are dealing with in 17, and that is this title. So let's go to the document cam. Well, that'll make Ernie work hard here. He's got 3 things to do all at once. Lesson 17, division of decimal fractions. I don't know how to do this, really. I know how to do 4 into 1, but let's say I had this problem. 1 over 4.2. Not a 4, but a 4.2. I don't know how to do that problem, so what I'm going to do is get rid of the decimal. I'll multiply by 10 to the first. Multiplying by 10 to the first moves the decimal 1 place over to the right. That was yesterday's review. Multiplying by a power of 10 moves the decimal point to the right. The exponent tells you how many. 10 to the first says move it 1 place. Now note, there's a decimal after that 1. It's not written, but it's there. So this becomes 10 over 42. And I know how to do that. So I'm going to take my 42 and divide it into a 10. And then what am I going to do? Put the decimal point after the 0. And how many zeros? I could do 2, maybe 3, maybe 4. I'll go 3. Again, if you have more than you want, you can throw them out. No cost, no penalty. Okay, so it's a win-win. Poor decimal. Now, wait a minute. Decimal does not feel badly when you throw it out. Okay, they are emotionally deprived. Zeros. 42 won't go into the 10, agreed? Do I want to put the 0 in front? It's optional. What area is it not optional? We talked about, well, the next, I have to have something here. But the question is, what field of study is that 0 important? I talked about it earlier. In the nursing area, because they want to know a decimal points there. You don't usually put zeros in front of the number with all due regard to 06 when we write the date. But typically, we don't. Okay, 42 into 100, I hope you realize that goes about 2 times. So we get an 84, and we subtract and get what? A 16. Bring down another 0. And it won't go 4 because that would give me 168, so we will go to a 3. And then I get a what? 126. And the question, will this ever stop? We don't know. It might later, but I don't know out of hand. I suspect it won't stop, and it has a lot to do with the factors of 42. I like that, poetic. A lot to do with 42. Now, the idea is that there's a 7 and a 3 as a factor of 42, and we know what happens when you divide by 7. You get that string of 1, 4, 2, 8, 5, 7 in some arrangement. And if you divide by 3, you get what? Okay. If you divide by 3, you get a bunch of 3s, typically. Although in 2/3, you get a bunch of what? 6s. So it's not a sort of guarantee, but it's a suggestion that this is not going to go well. Nonetheless, I subtract. I'm just going to bring this up because I ran out of room. And what is 26 from 60? 34. Bring down a 0. And what's the next digit going to be then? 42 into 340. 8 or 7. What's your argument? Can't be 9 because 9 times 4 is 36. 8 times 4 is 32. What do I have to be worried about? The carry, because 8 times 2 is 16, and that carries a 1 there, which makes this a 36, and that means I'm down, whoops, did I go too? Not 33, how about 33? I was thinking of a, I don't know what I was thinking about there. How about a 33? And so I get a 4 here. And then what? A 0, that's a 0, and then I go to 400, and this is looking like it could go on a ways. So this question, how far do I go? Oftentimes you will hear me give the direction, round off to the nearest, and then I'll give you a word. So in this case, let's say hundredth. So if I ask you for that, what is your answer? 0.24, because this next digit is 5 or more. You raise the 3 to a 4 and then throw the garbage out. We got it? Now that's pretty much the process. Now some of the problems look at times a little bit more bizarre than that. Let me give you an example of something that's a little more bizarre. Not yet. 5's a nice divisor. We're going to choose some numbers here. Ernie, give me a number between 1 and 9. 2. Okay. A 7, thank you. Anybody else?
4.
A 4. Anybody else? 3. A 3. Now stop for the moment. I'm going to throw a decimal at this, about here. And I want the next digit guarantees me.
5.
Thank you. It has to end in a 5 or a 0. You had two choices. If what? This 5 will divide into that. Now, what do I have to multiply times this decimal to get rid of the decimal point? Well, I've heard a 3 and a 4. Do I hear a 5? A 6? A 7? I haven't heard the right number yet. Thank you. I heard a 5. And it has nothing to do with this 5. It has to do, where do I want the decimal? At the end of the 5, even though there were 4 zeros, I've got to go 5 places. Huh? Okay. Merlot excuses again. Now we're going to go here 10 to the 5th. Do you usually have to show this multiplication? No. But I'm wanting you to understand we're moving to the right because we're multiplying by a power of 10. What do you usually do? You just take this over and you go, oh, I go that far, and then what do you have to do here? Same number of places, so what am I going to have to do in this case? Add 2 zeros to make it happen. I'm going to trade in the original because it's looking messy. Oh, this is ridiculous. Why did I let you give me these numbers? It's not your problem with the numbers. It's where I located the decimal point. Okay, are we ready? Short division. Are we ready? You're supposed to say yes, born ready. Okay, 5 into 27. A 5, remainder. 2, 5 into 24. 4, remainder. 4 for a 43. 5 into 43. 8, remainder. A 3 for 35. A 7. Thank you. So, my answer. Now the question. In this answer, which is 548,700, we typically put a comma there. That is a very bad looking 8. Does that read better? A little bit better. Do we have to put this decimal here at the end? No. I heard 1 yes, 1 no. Is it optional? Yes. It is optional. Adrian, you should know. And the answer is you can put it there or not. It would confuse many people. I would leave it off. Have we got it? So the point is, this wasn't such a bad divisor once you got rid of the decimal point. Not a bad problem at all. A rather large answer. This brings up a very interesting thing. If you divide by a very, very small number, you get what? A very, very large answer. That becomes critical in mathematics. One more comment. What is the size of that number? Will you name that for me in verbal notation? So I have 4 zeros and a 5 in verbal notation. Okay. You were right. I heard an answer behind me quietly given, but I won't share it. Let's see if you can come up with it. Write me the verbal notation for this. Smug, huh? Okay, the answer in verbal notation for this decimal. No. Adrian already screwed that up, but nobody listened to him. I don't know why. I mean, it happens. Okay, 0.0005 in verbal notation, meaning I want you to write it, not verbalize it. Okay, you should have written something that starts with a 5. That's the hint. Then the question. And ends in a THS. Fill in the gap. Okay, tenths, hundredths, thousandths, 10,000ths, 100,000ths. So we have 500,000ths. Very small number. Just from yesterday, for those of you who weren't here so you can review a little bit what we did yesterday, how would you write that in scientific notation? 5 times, good. 10 to the negative, good. Is it negative 4 or negative 5? Negative 5, because the decimal point after this is here. That was a bad statement. The decimal point in 5 is at the end of the 5, and I need it to go back, what? 1 place just to get it there, and then 4 more for the zeros. So that's 5 places to the left, negative 5. That was scientific notation. And what is 10 to the negative 5 also known as? Just the 10 to the negative 5. How can I write that in a different form?
Oh, the division.
As a division, you are correct, but what division? 1 something. 1 over?
1,0,0,0,0.
Okay, you could, or just say 10 to the 5th. So if you have 10 to the negative 5, it's the same as 1 over 10 to the 5th. Now, where do we use that idea that we've done earlier? Probably should have one more coming out here. Place value. This is a 1, correct?
Yep.
Also known as?
10 to the first.
10 to the 0, okay? And 10 to the first, and 10 to the second, also known as 110 and 1. Okay, to the right.
10 to the
10th. How do you write a 10th? Symbolically. 1 over 10 to the first, but that's 10 to the minus 1. And then 1 over 100, which is 1 over 10 to the second, so that's 10 to the minus 2. And so we stair-step down with the exponents. 2, 1, 0, negative 1, negative 2. It's like a temperature that's dropping below 0. So what's the next one? 10 to the negative 3, which is 1 over 10 to the third, which you know as 1,000th. So that's where we've been using that idea with expanded notation. It's a very important idea. Now let's say I give you a problem like this. What are you going to do? Are you going to do long division? I don't have to move any decimal because where's the decimal in this already? At the end. It's where I want it. Do I want to do long division? Not if I can avoid it. How do you avoid this? What is another way of writing that problem?
4, 5, 7, 5, 6, 3 over 10.
Go ahead.
Over the 10 to the.
Over the what? You said 10, but you didn't finish it off. 10,000. Okay, so what I'm being told, to share it with everybody watching, is to rewrite it this way. That's a good first step, but I'm not real happy about that yet. Rewrite it one more time for me. 10 to the power. Okay, that's a nice way of telling me that I'm going to do something without committing. Okay, so I'll fill in what I've been told. Somebody help out here. 10 to the what? All you have to do is count the what? Number of zeros, and there are 4 of them. So that's 10 to the 4th. But what do we do with the decimal when we divide by a power of 10? Move it to the right, left? Which way does it go? Why do we want to move it to the left?
Because it's not a negative. Power's not negative.
That's what you do when you divide. That's a rule. And you've been listening to those rules very well, right? Okay, let's get it so it's sensible. When I divide by a power of 10, shouldn't I get a smaller number?
Sure.
If I'm dividing by 10,000, it's going to get small. How do you make a number small? By moving the decimal to the right or the left? I thought that would be a very quick answer.
To the right.
I'm hearing 2 different responses. If I move this decimal to the right, it's going to be instead of 475, 4,000, 47,000, 475.
To the left.
So you move it to the left to get it smaller, and I'm dividing by a big divisor, so that says this has to go to the left. So how many places?
3.
4 places, because I have 4 here. So the exponent here, I know it, well, you weren't here, so the exponent here is going to tell me that I'm going that many places to the left. So what does that tell me I have to do?
Add a 0.
Add a 0. So I'm going to put the 0 in front of the 4. Agreed?
Yep.
Because this was here where I'm pointing at the 5, and I went over 4 places to the left. Okay? So that is 0.047563, optional 0 in front of the decimal point. When I give you a problem like this, I want you to rewrite it this way before you get your answer. If you decide to divide 10,000 into this with long division, I will give you only half credit. So you suffer more and get less out of it, is the argument. Okay, any question in that problem?
Is it in the homework?
Yes, it is. Question was, is this in the homework? You betcha. Okay, which brings us then maybe to looking at the homework problems. So I'll just leave this here, Ernie. I'm going to go back to the camera area. So we'll leave that on the screen momentarily. And we are going to look at the kinds of problems that you're going to enjoy for the homework. Oh, joy, said with absolute insincerity.
I'm singing a happy, happy.
Okay, here we go. These are on page 169. You recognize 169?
Prime.
169. Can't be prime.
Oh, it's division.
Okay, well, just let that go for a while.
What is it?
Do you recognize it as a perfect square? Let's come off there for a moment, Ernie. Do you recognize it as a perfect square? Okay, let's review some perfect squares. 10 squared. 10 times 10.
100.
Adrian. 10 times 10 is 100. Okay. 11 times 11.
111.
Close. 121.
121.
121. 13 times 13. Try multiplying it out. Multiply it out for a moment. 13 times 13. What number?
169. 169.
I'm going to take that bottle that the Merlot came in it and do something with it other than... Okay, how about 169? Right? 169. Okay, what page number were we on? 169. What perfect square did it represent? 13. Okay, now we can look at the problems, Ernie. Okay, these are problems like we've been talking about. I would not expect you to multiply by powers of 10, but you do have to move the decimal points around appropriately. So as we come down to the bottom of that page for a moment, Ernie, as we come off for just a moment, in this problem, this is part F. It's pretty much what we've been just doing. Shouldn't cause you too much of a headache. So coming off there, we'll turn the page. And these are the kinds of problems I just talked about. So let's look at part C, page 170, which is not a perfect square. How are you going to rewrite that? First step, based on what I just asked you to do in the board. Ernie, will you cut to the 10,000 into 475.63 in the board, please? See what we did there on the screen? Hertz bars and all. Okay, so we had rewritten as over 10 to the what? 10 to the 4th. So coming back to the document, Cam, I'm going to rewrite this as what? First step. 0.046 over 10 to the 2nd. Good. Okay, coming off there for a moment. And Ernie, just a question. Why did we have Hertz bars coming across on that last shot? Yeah? Okay, the preview camera. So if you don't preview, no Hertz bars.
Correct. You see, I just turned it off.
Oh, okay. Turn it back on. Are you seeing any Hertz bars? Oh, camera 2. Okay. Okay, here's. So you folks know what's happening. We'll take a look at this one. Go back to the cut we had in the board. Okay. What I was, see that little bar going across? That's a Hertz bar, rolling bars. Then you're going to turn off the what? Oh, the preview monitor and the Hertz bars go by. Okay, now we have that.
I can still see it.
You can.
I'm married to a cable man, I'm sorry.
Okay.
And he's not an installer.
Now, as we come back to review test 17, for those of you who have been watching and wanting to know what the bars going by, reference. They are referred to as Hertz bars, like in megahertz, gigahertz, that kind of thing. So we want review test 17. Not that you really wanted to know why the bar was going by that fast. I guess we could talk about bar hopping and all sorts of. Going on to page 215, which is 10 less than a perfect square. What perfect square am I referring to? Add 10 to that and you get what? 215 plus 10 is 225. What is that the perfect square of? I heard one correct answer and one wrong answer. That's it. You don't. 225 is 15 squared, so that was correct. Okay, let's go back to the document, Cam. And this is what we've been doing, same kind of problem. So that's not a difficulty, but let's come down to, I guess you can still read it there. This next one you have to be careful about. You're going to find your answer to the nearest what? Hundredth. We did that on the board. And be careful. Ernie, will you take camera 2 and go over to the point where we had 42 into 10 and did that to a 0.2380 and rounded off. So just a reminder as we look at that. Got to keep Ernie hopping on the keys. Notice we rounded that off to 0.24. Rounding off to the nearest hundredth. That's what you're going to do in this problem as we come back to the document, Cam. You're going to do that same kind of problem in both 2A and 2B. You can't see 2B, but I'm going to bring it there. That's an interesting problem. Now that's 1, 2, 3, 4 into 4, 3, 2, 1. And I need to give you some history in that problem. Because the history of that problem comes back to the Scientific American and a column written by Martin Gardner. He wrote a column for the Scientific American. No, that's not the shot I want. There we go. Martin Gardner wrote a column for the Scientific American, and he gave this problem one time, and it is in one of the supplementary units you can look at that I originally wrote for this course. And here's the problem for your viewing pleasure again. Well, number of things. Okay, now, he expected this to be carried out for about 10 digits after the decimal point. And he called this a short, long division. And it was supposed to be a nice arithmetic discursion. Something that just, takes your time and you just have fun. Question, does this repeat or does it terminate? Now, I don't have a good answer for that. I had a student who got very fascinated with this problem and carried out about 30 pages on this problem trying to see if it would repeat and didn't discover a repeating pattern. And I haven't taken time to look at it since. But it's a very neat problem. If you do it with the low stress method, you multiply 1 times this, then 2 times this, then 3 times this, and 4 times this, so you don't have to keep doing those multiplications. Low stress method, and it's a neat problem. It starts with an 8. So I'll give you a hint. Okay, now, with that said, let's go back to the document can. See, I just took a low version of that. 1, 2, 3, 4, 4, 3, 2, 1. But you can picture what I could do in a test. I could do 1, 2, 3, 4, 5 into 5, 4, 3, 2, 1. And we could have fun doing that. Coming off that, these two problems in the next part, this is number 3. The shortcut I'm referring to is what we just talked about, as is number 4. So you just use a shortcut in those two parts. And then, as I slide over, coming off there for just a moment, on these two parts, one's a shortcut and the other is, be careful in part B at the bottom of the screen. I would put the 0.09 below the 1.64 to multiply. Otherwise, it's just an awkward problem. And finally, as we come off there, these I'm not particularly excited about. I gave these two common fractions, and I wanted you to write the decimals. And my effort here was to convince you that common fractions as decimals are either terminating or repeating, one of the two. So that is lesson 17. What we do next is with percents, and I want to tell you where we are going to be tomorrow, because this, along with lesson 6, I think is one of the more demanding reviews we do. We are going to, in lesson 18, look at a common fraction, a decimal fraction, and a percent, and bounce back and forth between the three. Now, my metaphor for this is like juggling 3 oranges. If I ask you to just juggle 2 oranges, it's not bad. Put a third one in, and it just tends to be oranges on the floor. I'm going to give you a common fraction, ask me to give me the decimal. And then I'm going to start with the decimal and ask you to give me the common fraction. Or start with either one of those and get a percent. So what we're going to have is a kind of triangular arrangement going back and forth. That's where we're going to be tomorrow.